Hello, and this video is going to be on lesson 3-3 and 3-4. Lesson 3-3 begins on page 42. So the lessons for 3-3 are to add, subtract, and multiply matrices, and to use a graphing calculator to perform operations on matrices. Okay, so first of all, we want to learn what is a matrix. And what the book says is that a matrix such as matrix A below is a rectangular arrangement of numbers written inside brackets. So this is a matrix right here. These numbers in the brackets, and the way we represent a matrix is with a capital letter. Now it could be any capital letter from capital A to capital Z. So in this case we have capital A. Now, let's take a look at this matrix. How many rows are there? Rows, we have 2 rows. How many columns are there? Well, if you forget what columns are, think of columns from the Colosseum in Rome. They are vertical pillars. So, as you can see, we have 3 vertical pillars, or 3 columns. Now, the very first thing that we want to learn about a matrix is the dimension of a matrix. Dimension of a matrix. Now, the dimension of a matrix is going to be the rows by the number of columns. And it's always in this order. Rows are going to go first and columns are going to go second. So if I were to find the dimension of matrix A, it's going to be a 2 by 3 matrix. So the dimension of matrix A is 2 by 3. Again, rows are always going to go first and columns always go second. Okay. Now, what if we were looking at the numbers inside of this matrix? The numbers inside the matrix are called entries. So here's entry 2, entry 4, entry 8. Now let me ask you this question. I know that 8 is inside my matrix, but can you tell me specifically where inside the matrix is entry 8? How would you be able to describe that for me? Well, let's use rows and columns. So first of all, which row is entry 8? It's going to be in the second row. So entry 8 is in the second row. And what column is it in? It's going to be the second column. So if I actually highlight or circle the second row and circle the second column, you can see that the circles overlap exactly where 8 is at. So that gives me a very precise address of where entry 8 is inside the matrix. Okay, let's answer this next question. Where inside the matrix is entry 2? Okay, so let me go ahead and take a look at where 2 is at. It's going to be in the first row. And I can see it is in the first column. Okay, so if I highlight the first row and the first column, I can see that my circles overlap at where 2 is exactly at. Okay, so we found the address of entry 8 and the address of entry 2. What if I were to ask you, okay, tell me where entry number 4 is going to be at, and 5, and -3, and -2. If we write this out, we're going to have a long list of addresses. And so there has to be an easier way of writing the address. Well, there actually is. What I'm going to do, in order to write a simpler way of finding the address, is entry 8. Notice that this matrix is represented by a capital A. So when I'm describing an entry inside the matrix A, I'm going to use a lowercase a, and I'm going to use two numbers. The first number represents the row that entry 8 is in, which I found to be 2, and the second number represents the column that the entry 8 is in, and that is the second column. So there we go. This is going to be a simpler way to write the address of entry 8, where we have lowercase a to second row and second column. Let's look at entry 2. Again, we're still looking at matrix A, so the entries are going to be represented by lowercase a, and this time it's going to be in the first row and first column. So as you can see, the first number, again, going all the way back to the dimension, it's following that same order, where rows goes first and columns go second. So if I wanted to find where entry -2 is going to be, again, it is still in matrix A, so I use lowercase a, and it's going to be in the second row, third column. So a, lowercase a, 2, 3. So these are definitely simpler ways of finding the address, writing the address of an entry inside the matrix. Alright, so what I had you do is basically answer questions 1, 2, and 3. And notice, let's take a look at number 2a. Notice that I have lowercase b. So if I have lowercase b, which matrix am I going to look at? Is it matrix B or matrix C? So for lowercase b, that is an entry inside matrix capital B. And if you have an entry with lowercase c, that is going to be inside matrix capital C. Alright. Okay, so let me just give you answer the A and C just to give you an idea of what to expect. I'm looking at lowercase b, an entry in matrix B, and the first number represents the row, so the third row, and the second number represents the column, so this is going to be the first column. And you can see where their circles intersect, they overlap at -4. Okay, now this time I have a lowercase c, so I'm looking at matrix C, and the first number represents the second row, and then 1 represents the first column, and so my entry is 26. Okay, so we learned about the matrix, 3 important things. We learned about the dimensions, the dimension of a matrix. By the way, the dimension of matrix A is going to be 2 rows by 3 columns. We learned about the numbers inside the matrix are called entries, and to tell specifically where a specific number is inside the matrix, we used the address. So the next thing that we want to learn about is how to add matrices together. So let's take a look at the dimensions first. The dimensions of matrix C is going to be 2 rows by 3 columns. the dimension of matrix D is going to be 2 rows by 3 columns. And here's a very important rule. You can only add or subtract matrices if the dimensions are exactly the same. So, let's write that rule. You can only add or subtract matrices, and by the way, matrices is plural and matrix is the singular. So you can only add and subtract matrices if the dimensions are the same. So, can we add matrix C to matrix D? Yes, because they are the same. Now, let me have you use your intuition here. When I add matrix C to matrix D, what do you think the dimension of the sum of those matrices are going to be? Well, some of you were able to guess really well. The dimension of the sum of the matrices is going to be also 2 by 3. What about the dimensions of the difference of the matrices? Again, some were able to guess correctly. It's going to also be a 2 by 3 matrix. Now, let's focus on adding matrices. It's very simple. You take the entry in the first row and first column and add it exactly to the second matrix, to the entry of the second matrix in the first row and first column. So 2 plus 5 gives me 7. And you keep doing the same for all the other entries. So here we take the entry in the first row second column and add it to the second matrix to the entry of the first row second column. So 8 plus 0 is 8. 10 plus negative 2 is 8. Negative 3 plus 8 is 5. 1 plus 7 is 8, and negative 5 plus negative 4 is going to be negative 9. So it's as simple as that. That's all you have to do. Alright. Same thing with C. C minus D. And let me actually write it up here. So this is C plus D. And we are doing C minus D. Exactly the same way that we added the matrices. So this time we're subtracting. So here we have the first entry, which is in the first row, first column, and subtracted to the entry in the first row, first column of the second matrix. So 2 minus 5 is negative 3. 8 minus 0 is 8. 10. Now, be careful here. What goes here is not going to be 10 minus 2. It's going to be 10 minus negative 2. And so when you have two consecutive negatives, they become a positive, and so this is actually 10 plus 2, which is 12. So be very careful when you're subtracting matrices. Here we have negative 3 minus 8, which is negative 11. 1 minus 7, which is negative 6, and negative 5 minus negative 4 again. You want to be careful with negative numbers when you're subtracting matrices. Negative 5 minus negative 4. Two consecutive negatives become positive, so negative 5 plus 4 is negative 1. Alright. It's very simple to add and subtract matrices. Okay, and what I had you do next is answer questions 5 through 8, and also I had some practice problems from inside the book where you could practice more adding and subtracting matrices. Alright, now the next thing that we did is finding how to multiply matrices. Let's go ahead and take a look at this, and here we have matrix M, and let's go ahead and write the addresses. So 3, since I have matrix M, I'm going to use a lowercase m, and I'm going to see that 3 is in the first row, first column, first row, first column. 4, entry number 4 is going to be in the first row, second column. Entry -2 is going to be in the second row, first column. And finally, entry 5 is going to be in the second row, second column. Okay. So this is going to come up later, but let's go ahead and take a look at what is necessary in order to multiply matrices. So first of all, let's take a look at the dimensions of each of these matrices. The dimension of this matrix, we have one row, and don't get confused, just because we have just one row, these numbers, each of these numbers represents a column. So we have 3 columns right there. So this is a 1 by 3 matrix. Here we have 1, 2, 3 rows and just one column, so 3 by 1. Now, there's something very important in order to be able to multiply matrices. In order to multiply a matrix, the columns of the first matrix, so the number of columns in the first matrix must equal the number of rows in the second matrix. So an easy way to find that out is just write the dimensions on top of each matrix, and if the inside numbers match, and only if the inside numbers match, you can multiply the matrices. So again, the number of columns in the first matrix must equal the number of rows in the second matrix. So in this case, they're both 3. Then yes, we can multiply these together. But what does it look like when I'm multiplying 2 matrices? Alright, so that's what we want to do. And it's actually very simple. We're going to take the first entry of the first matrix and the first entry of the second matrix, multiply them together. So 1 times 3 is 3. And I'm going to add the product of the second entry in the first matrix and the times the second entry of the second matrix, so that's going to be 2 times 2, which is 4. And finally, I'm going to multiply the last entry of both matrices, and that's going to be plus 16. And so what I get is going to be 3 plus 4 plus 16, which is 23. Now, this is my answer. So let me write the dimensions again. I have 1 by 3 and 3 by 1. Now there's something special about, well, we circled the 3's. They have to be equal to each other in order to multiply. But there's something special about the outer numbers. Once you write the dimensions above the matrices, the rows of the first matrix and the columns of the second matrix, if you take those outer numbers, that gives you exactly the dimensions of the product of the matrices. And so if you look at this, 23 is a matrix. This is a matrix. This is a 1 row by 1 column matrix. And so that is always going to be true every time you multiply matrices. The rows of the first matrix and the columns of the second matrix are going to give you the dimensions of the product of the matrices. Alright. So this was a very simple example. Now let's take a look at a more complex example. First of all, can I multiply these matrices together? So the first thing I want to do is write out the dimensions. Here I have a 2 by 3 matrix, and here I have a 3 row by 2 matrix. Can I multiply these matrices together? Well, does the number of columns of the first matrix equal the number of rows of the second matrix? Yes. I can multiply these together. Now remember, if I can multiply these together, then the outer numbers give me exactly the dimensions of the product matrix. So when I multiply these together, it's going to give me a 2 by 2 matrix. So A times B is going to give me a 2 by 2 matrix. But how am I going to find the entries that go inside there? Okay, what I'm going to do first is I'm going to write the addresses that would go here. So remember, when we looked at this 2 by 2 matrix that we called M, we wrote the addresses, and basically the address of 3 is 1 1, the address of 4 is 1 2, the address of negative 2 is 2 1, and 2 2. So if I were to just create a 2 by 2 matrix that we have here and just write the addresses, it will look like this. So the address of this, whatever goes here, is always the first row, first column. The address that always goes here is always going to be in the first row, second column, and second row, first column, and second row, second column. So all I did here was write the addresses. This is always going to be the same address for a 2 by 2 matrix. So let me go ahead and write the addresses here. That's all I did. This is not the answer, by the way. This is going to be a guide for me to find exactly what is A times B. So, alright. Now, how am I going to use this? This is actually going to be very useful. Instead of looking at these as addresses, the first number is going to represent the rows of the first matrix, and the second number represents the column of the second matrix. So here's what I mean. 1 1, the first one represents the row of the first matrix, and the second number represents the column of the second matrix. So first row, first column. And this is what I'm going to multiply together in order to find the entry of my 2 by 2 matrix. So remember how I multiplied these? Exactly the same way I did this example. So what I want to do is multiply the first number in my row by the first number in my column. So it's going to be 1 times 2, which is 2, plus 5 times 3, which is 15, plus negative 4 times 0, which is 0. And when I add these together, 2 plus 15 plus 0, the sum is going to be the first entry of my A times B matrix. Okay. Let's go ahead and take a look at what goes here. So looking at this guide again, it says to look at the first row of the first matrix and the second column of the second matrix. So now these are the ones that I'm going to multiply together. And so just as what we did here, I'm going to take 1 times 4, 5 times -1, which is -5, -4 times -2, which is +8. Okay, when I add these together, 4 minus 5 is -1, plus 8, which is 7. Okay. I can go ahead and erase this. So can you see how we're using the addresses that we got from here, and instead of using them as addresses, we're using them as a guide to know what we're multiplying together. So here we have 2 represents the second row of the first matrix, and the 1 represents the first column of the second matrix. Okay, so again we're going to multiply these together. So 3 times 2 gives me 6, -2 times 3 is -6, and then 2 times 0 is 0. So basically 6 minus 6 is 0. Alright, we're almost done. And finally, I'm looking at the second row and the second column. And so we have 3 times 4, which is 12, -2 times -1, which is +2, and 2 times -2, which is -4. 12 plus 2 is 14, minus 10, minus 4 gives me 10. Here it is. This is exactly the answer. This is the product of the matrix. Right there. Okay, so I showed you how to add and subtract matrices, and I showed you how to multiply matrices. So now I'm going to show you how to use a graphing calculator to perform operations, those exact operations. So let's verify if matrix A times matrix B does in fact equal 17, 7, 0, 10 inside there. Alright, so let's take our calculator, go to the home page, click on the calculator button, and the way that we can verify this is first we need to know how to input a matrix. The way you do that, you click on this button right here, highlighted in red, and we need to create a 2x3 matrix first. So I'm going to click on this symbol that looks like a 3x3 matrix, and it's going to come up with a menu where it asks you for the number of rows and the number of columns. So we need a 2x3 matrix. So we're going to need 2 rows and 3 columns. So you're going to press tab to go to the columns. We don't need to change that, so we can just go ahead, press tab again, and hit OK. So here we come up with our 2x3 matrix, and we just fill in the entries. You can use your arrow button to move in between entries. Okay, once you input the last entry, you're going to press the right arrow to get outside of the matrix. Now, you can go ahead and hit the multiplication symbol, but since we're multiplying matrices, if you just put them side by side, it's already the computer assumes that you're going to be multiplying the matrices. But let's go ahead and put the multiplication there anyways. For now, the next matrix that we need to input is a 3 by 2 matrix. So again, hit your menu button. You're going to hit this 3 by 3 matrix symbol. The rows are going to be 3, but this time the columns are going to be 2. Press tab to go to OK and press enter. So now we're going to input the entries for this second matrix. Okay, once you put in the last entry, now is the moment of truth. Did we do our math correct? You're going to hit enter and take a look at that. It's exactly the same, 17, 7, 0, 10. So our math works out. Now, if we have access to calculators, why did I show you this method then? Couldn't I just have showed you how to do it on the calculator? Well, it's very important that you know how to do this, because maybe at home you do not have access to a calculator and you may need to rely on your technique of doing this by hand. So, and of course I gave you some more practice problems in section 3-3. And I also had you do these questions. Okay. Now we're ready for lesson 3-4. So we covered this on September 22nd, 2016. What I had you do first is solve this matrix. Now, the easiest method to use here was to use elimination. And so what we needed to do was multiply the second equation by -2. So let me rewrite the first equation. And when I multiply the second equation by -2, that gives me -2x plus 8y is equal to 4. Now, when I add these together, it gives me 0. 3y plus 8y is 11y is equal to 7 plus 4, which is 11. I can go ahead and solve for y by dividing both sides by 11, and y is equal to 1. Okay. So now that I have what y is equal to, I can just go ahead and plug that into the either equation. Let's just pick the first one. So I have 2x plus 3. Instead of plugging in writing y, I'm going to plug in 1 is equal to 7. And so I have 2x plus 3 times 1, which is 3, is equal to 7. Subtract 3 on both sides. And what I'm going to get is 2x is equal to 4. Divide both sides by 2, and so x is equal to 2. So here's my answer. Using elimination, my ordered pair is going to be 2, 1. That's my answer. If you use substitution, you should get the same answer. Now, so we use two methods. We've learned two methods of how to solve system of linear equations, either substitution or elimination. The past two lessons we've been learning about matrices, or the past lesson we learned about matrices. How can we use matrices to help us solve a system of linear equations? So that's what we're going to learn in this lesson. First thing I want to introduce you to is the inverse matrix. So if we have matrix A, and this is a 2 by 2 matrix, how do I find the inverse matrix? So we're gonna rely on a calculator to find the inverse matrix. So let's go to our calculator. Now, to input a 2 by 2 matrix, there's actually a shortcut. Instead of inputting the 2 rows by 2 columns, we can click on this 2 by 2 symbol matrix, and there we go. Right away we have that 2 by 2 matrix. So let's go ahead and input these values. we have 3, 4, -2, and 5. Now, it's actually very simple to find the inverse matrix. All I have to do here is in my calculator put what looks to be an exponent of -1. And so, because I put that exponent of -1, that is going to make it an inverse matrix. So the way I would read this is the matrix A inverse, or yeah, I think that's how you say it, matrix A inverse. So if we go back to our calculator, I'm gonna hit the right arrow to get outside of the matrix. I'm gonna hit this caret symbol here and put -1. If I hit enter, this is going to be my inverse A inverse matrix. So the inverse matrix of A is going to be this right here, 5/23, basically all those numbers inside there. So that is how you get the inverse of a matrix, simply by hitting the caret symbol and plugging in the caret symbols right here and putting in -1. Notice if we take the inverse of this matrix, it gives me back the original matrix. But the important thing is to know how to find the inverse of a matrix using your calculator. Okay, so going back to our original question, how can I use the idea of matrices in order to solve a system of linear equations? So let's begin. First of all, how many variables do I have here? How many different variables? Well, I have x and y, so I have 2 variables. The first thing I want to do is count the number of variables. That is going to tell me what type of matrix I'm going to create first. Since I have 2 variables, I'm going to create a 2x2 matrix. And what I'm going to put inside this 2x2 matrix is going to be the coefficients. Now, you have to make sure that the variables x line up and the variables y also line up on top of each other. So that's very important. And when they are, I can go ahead and take exactly in the way they are set up the coefficient of 2, coefficient of 3. Here we have a coefficient of 1, and here we have a coefficient of -4. So this 2x2 matrix is called my coefficient matrix. Okay, since I have 2 variables, my next matrix I'm going to write is going to be a 2x1. And what goes here in this 2x1 matrix is going to be my x and my y. This is going to be called my variable matrix. And finally, this is going to be equal to another 2x1 matrix. Now, how do I know what the dimensions to make these? Well, the 2, again, because we have 2 different variables, that tells me to do a 2x2 matrix. And a 2x1, no matter what type, how many variables you have, the columns are going to be 1 here, and same thing here. What really changes is going to be the rows and this matrix here. Okay, so finally, in my last 2x1 matrix, I have the constants of 7 and -2. So this is called my constant matrix. Okay, this is something new. So the important thing you have to know here is how to look at your system, how to go from your system into this matrix equation. So this is very important. How do you go from a system into a matrix equation? So once you get familiar with how to set this up, let's go to the next thing. Now remember when we took a look at how to find the inverse of this matrix, remember the matrix is always represented by a capital letter. So going here, this 2 by 2 matrix, we're going to represent it by the letter A. Now this variable matrix here, I'm going to represent it with a capital X. So this is A times X. Again, remember when I put matrices side by side, it is implied that we are multiplying them. Equals, now since I already used capital A, then I'm just going to go down the line and call this matrix B. So, this is matrix A, matrix X, A is equal to matrix B. Okay. Now taking a look at this, I asked my students, what does this look like? And very intuitively they answered, it looks like an equation. And so if this was an equation, what am I trying to solve for here? I'm trying to solve for x. So what do if this was a regular equation, linear equation, what would I need to do to solve for x? Well, I would have to divide by a on both sides, and so then x equals b over a. But since these capital letters represent matrices, notice that at the beginning of our learning targets, we learned how to add, we learned how to subtract, and we learned how to multiply matrices. Why did we not learn how to divide matrices? Well, dividing matrices does not exist. You can't do it. So if we can't divide by matrices, then how am I going to solve this right here? How am I going to find my X matrix? Remember, my X matrix are basically what my variables contain, my variables X and Y, which is what I want to solve for. So this is where the inverse matrix comes in. Instead of dividing both sides by A, what I'm going to do is multiply each side by the inverse of matrix A. So here's my inverse matrix A times X is equal to the inverse of matrix A times B. So as you can see, instead of dividing by A, I'm going to multiply by the inverse matrix of A on both sides. Now, when you do this, it's very, very important that the inverse matrix of A goes first, and then matrix B goes second. Because if you do matrix B times the inverse of matrix A, that is going to give you the wrong answer. So this is a rule. The inverse of matrix A goes before matrix B. Okay, so since I did multiply by the inverse of matrix A on both sides, what do you think is going to happen to the inverse of matrix A times the matrix A? Well, that is going to go away. And so what I have here is X is equal to inverse of matrix A times matrix B. So now let's write what these capital letters represent. This basically represents XY, and this is going to be 2, 3, 1, -4. Inverse, don't forget that inverse there times matrix B, 7, negative 2. So this here is what I'm going to plug into the calculator. This right here. So let's go ahead and take our calculator. Right there. And the first thing I want to do is input a 2 by 2 matrix. So just using the shortcut right here. Okay, let me do that again. There we go. I'm going to put in my entries of matrix A, 2, 3, 1, and negative 4. Now you don't want to forget your inverse. This is inverse, so you're going to hit the caret symbol to negative 1. And now I'm going to input, you don't have to put the multiplication, but you can if you want to. Here's a shortcut for a 2 by 1 matrix, which is what I'm looking for. And I'm going to put in my matrix B, which is 7, negative 2. Okay. Let's go ahead and hit enter and see what we get. 2, 1. So this is equal to a matrix, a 2 by 1 matrix with entries 2 and 1. So if we put these side by side, can you see how we can get our answers for x and y? X is going to equal exactly what is in the first row, first column, which is 2, and y is going to be equal to exactly 1. When we solve this using substitution, it's exactly what we got here. X equals 2, y equals 1, and so putting my answer in an ordered pair, we get the exact same answer, 2, 1. So this may have seemed tedious, setting it all up and putting it inside the calculator. But to simplify the process, there's only one thing you need to take away from this formula right here. So let's go to, so I already had you do this homework and you already turned it in and you already got a grade. So now let's take this question that we had, and instead of using S, M, and L, I'm going to use X, Y, and Z. So remember how we set the equations up. It's basically 6x plus 10y plus 8z equals 97.60. And very conveniently, all our variables are lined up, which is what is very important before you begin to write the matrices here. So again, here we have a 3 variables, so that lets me know that I'm going to have a 3 by 3 matrix. So our entries are going to be lined up very nicely. 10, 12, and 4. Here is my 3 by 1 matrix now, so x, y, and z is equal to another 3 by 1 matrix, which is going to be 97.6, 100.8, and 99.2. Now, remember, going back to the previous thing, the only thing I want to take away from this is this equation right here, this matrix equation, x equals A inverse times B. So let me write it down. What did I do here? Okay. X is equal to A inverse times matrix B. So this is matrix A right here. This is my X and this is matrix B. Now, I did not have to go ahead and set this up. All I had to do was just know what my matrix A is going to be, which are these coefficients right here, and write the inverse of it. So all I have to do to find my answers are to write matrix A 9, 12, 5, 10, 12, and 4, put the inverse on there and multiply it by matrix B, which are these numbers right here. So 97.6, 100.8, and 99.2. So just by taking this equation, I can apply it to any system of linear equations and set it up where I can find matrix A easily, put in the inverse of it, and multiply it by matrix B. Just remember this matrix equation. Use your calculator to plug it in. So first I need to create my 3x3 matrix. It's already set to that by default. So let me enter these values: 6, 10, 8, 9, 12, 5, 10, 12, 4. Simply put an exponent of -1, informally speaking, and then multiply it by a 3x1 matrix. So here my values are 97.6, 100.8, and 99.2. When I hit enter, it gives me exactly my XYZ, which is equal to 3.2, 4, and 4.8. So since I have 3 variables, this is going to be an ordered triple. So my X is 3.2, my Y is 4, and my Z is 4.8. There we go. So if you can immediately, looking at a system, if you can immediately identify what matrix A is going to be, which is basically these, and then put the inverse on there and multiply it by matrix B, which are the constants, you can easily use your calculator instead of using substitution and elimination to solve for your variables. So you need to remember the equation that X is equal to A inverse times B. That is going to be able to apply to solve this, to solve this, to solve any system of linear equations. So you just have to know how to identify what the matrix B is, and put that inverse in there and multiply it by the matrix B, and it's going to give you whatever variables you have. Alright, so that is lesson 3-3 and 3-4, and I had you work these. Okay, thank you for watching.